Alright. Hi everyone. So today I want to talk about the deep learning application in medical image analysis, which I has been researched. So first of all, uh, as you know that in 2007 to 2012, the electronic health record is increasing triple time from 11.8% to 39.6%. And the diagnostic imaging playing a big role in the artificial intelligence system and also the medical record. So there are so many different type of medical imaging, such as ultrasounds, X-ray, and CT. So, with the advantage of machine learning in an era of medical uh, big data, and it is significantly impact into the decision making and relationship between the machine learning and medical field. So today I want to talk about two type of learning model is the supervised and unsupervised. However, in the supervised, we would mostly focus on the convolutional neural network um, and recurrent neural network, which is the two type that we have been study. And the last one is belong to unsupervised learning model is autoencoders. However, since we have do not have so much time, that's why I only talking about the three type of learning model. So first of all, as you know, as everyone know that about the convolutional neural network, which is CNN. Uh, in CNN, uh, the is the most popular machine learning and which is applied in variety areas such as classification, localization, uh, segmentation, and registration. Um, uh, because as we know that from both from the set two-dimensional or the three-dimensional structure of an organ, it can go that are being studied and classified target either normal or abnormal. CNN because the CNN is able to capture the most important feature relationship in an image. So as we know that the when we have the input image, it can go to a different layer for right here such as convolutional layer, ReLU, and pooling layer. Then it's gonna go to a filter, which reduce the dimension of the image into a one dimensional, and then the output is either normal or abnormal, which is a very powerful tools for classification in medical report. The second thing I want to talk is the recurrent neural network, which is RNN. Um, RN, as we know that the RNN have a traditional being used in analyzing sequential data, such as the words in a sentence, and has the ability to generate text. And so for that feature, INN have been applied in the text analysis task, such as machine translation, speak recognition, language modeling, text prediction, and image caption generation. Um, so the output of the layer of the layer is added into the next input is the feature of the INN. For that, so it's suitable for the segmentation. Um, However, there is one thing about the INN is the vanishing gradient. So for that problem, to avoid it, the back propagation is implemented through time. and which causing INN to evolve into another feature or another type, which is the long short-term memory LSTM. Uh, with that, the LSTM is used for microscope image of neurons as well as MRI brain scan, and also able to describe annotating X-ray image with caption trained on radiology report. Um, the la- now now I will talk about the unsupervised learning model, which is the autoencoders. So the autoencoders can learn feature representation of input data in an unsupervised manner without the label data. So the model will take the input data and then use the code to reconstruct the output data. So the structure, as you can see that from the image or from the architect, the input is go to the hidden layer, and this code will reconstruct the output data. Uh, the label of output must be closely similar to the input data as possible. Um, s- uh, so there's one unique about the architectural feature is that the auto encoder uh, about the autoencoder is that the number of neurons in the input and the output layer must be equal. They must be equal. So one more thing is the hidden layer of autoencoder can be stacked like CNN. So which come up to two type of autoencoder is the stack and the noising. For stack encoder, autoencoder is have a symmetrical architecture and with a line of reflection to the middle of hidden layer. So this technique is would would increase the performance. However, simply stacking up more layer may not improve the quality of the model and may not learn any useful feature representation. And the only thing that increasing is the runtime. For the noising autoencoder is a feature of using Gaussian noise and added into the early hidden layer, which will forcing the model to learn useful code to generate back the noise-free input in the output layer. So in conclusion, traditional application for medical analysis are include prognostication, content-based image retrieval, image report, or caption generation, manipulation of physical object with LSTM and reinforcement learning. However, there are also challenges. The data are mostly lack of label, general lack of publicity data, and high quality data is even more little or scarce. So the data, the, and also one thing is that the data or class is imbalanced in the training, and also which is significantly impact in the medical image analysis. So in the future, there would be more different model or architecture that would be suitable to solve this challenge and create a better result. Thank you.